Here I'll be explaining about the hovercar. This hovercar has 6 individual motors which are powered by electricity and do not run in any combustion engine or fuel. These completely run on electricity and requires a battery to power itself. So what happens is we have 4 motors here which will be working as hovering motors. Since the name of the hovercar means, you can probably guess it does not have any wheels, but it has propellers that will allow it to float. So these 4 motors, it does the exact same thing, but here we have 2 motors which have a clockwise spin and 2 which has a counterclockwise spin. So the clockwise spin motors will be turning, and these will provide an upward thrust needed for this car to move up. But according to Newton's third law of motion, what is it? So when we have a reaction, it has an equal and opposite reaction. So if the action is towards this side, the reaction would be towards this side, and that we call it as a reaction torque. So to cancel out the reaction torque, I add 2 counterclockwise motors in a diagonal manner. So what happens is that if for this motor, if we see adjacent motor, it cancels out the reaction torque. Same for this, and if we take this motor, this clockwise motor counteracts the reaction torque provided by this counterclockwise motor. So this is what is happening here, and this motor provides an upward thrust so that the car can hover. Now if we focus at the part which will allow it to move forward, we have 2 motors, but here the difference is we take this pin as an example of a motor. So this is the part that will be attached to the car, and this is the part which will be attached to the propeller. So in these 4 cases, it will be placed in this manner. So this bottom part will be touching the car, and this part will have the propeller. But for this part alone, it will be in a different way. Here, if we have it in vertical manner, here the motor will be in the horizontal manner. The reason why is that when it's in the horizontal manner, it can only then provide forward thrust for it to move. And here again we have a clockwise spin and a counterclockwise spin, the same thing to counteract the reaction torque. And rather than placing it on the back, I have placed it on the sides so that the center of mass of this whole car is balanced, because this has a configuration of an X quadcopter drone. So what happens is the center of mass is concentrated at a single point, and if I place these 2 forward thrust motors in this manner, the center of mass stays the same, and it allows the craft to move forward more efficiently without consuming high amounts of energy, electricity. So but if I had these on the back, it would consume a lot more electricity. Why? Because when it's in the back, the center of mass shifts towards the back, and so when forward thrust is applied, the craft would tend to tilt upwards. So to cancel out that, these 2 motors would have to spin at a higher RPM, and this would consume a lot of electricity and a lot of current. So we would not want that. We want it to be energy efficient. So I add these 2 towards the center of mass so that it's much more energy efficient, and and the aerodynamics stays the same. Thank you.